NCERT Physics Class 11th 6th chapter, which is Work, Power and Energy. Now moving to first question, which is 6.1. So in this we have to define the sign of work, which is positive or negative. Different situations are given to us, and in this situation we have to indicate whether the work done by the given force is positive or negative. Moving to first part, work done by a man in lifting a bucket out of well by mean of rope tied to the bucket. So a man is pulling a bucket from well, and we have to find the sign of work done by man on this. So clearly it can be seen that if the man want to pull this bucket, so the force would be applied in upward direction. Let's say the force is F. The force is in upward direction and he is pulling the bucket. It means the displacement of bucket will also be in upward direction. So as we all know that work done is equal to F dot S. Work done by any force is given by F dot S, which is equal to Fs cos theta, where theta is angle between F and displacement. So in this case, the angle between force and displacement is equal to 0 as both are in same direction. So from this we can say that work done in this situation would be greater than 0. Moving to B part, work done by gravitational force in above case. So as we all know, due to gravity, the force acting on the bucket is mg in downward direction. And the displacement of bucket is in upward direction. So from this, work done is equal to F dot S, Fs cos theta, where theta is angle between the force mg and displacement s. From this we can clearly say that theta is equal to 180. So from this we get work done is negative. So work done would be less than 0. Moving to another part, which is part C. In this, work done by a friction on a body sliding down an inclined plane. So a body is sliding down an inclined plane, and we are supposed to find the direction of work done by friction. So from this we can say that suppose a block is moving in downward direction and this is theta. When the block moves in downward direction with velocity v, as we know, the friction, in order to prevent the sliding, the friction would act in upward direction, which is Fk, kinetic friction. As the displacement is in downward direction and the friction is in upward direction, so from this we can say that the angle between the displacement vector and friction force is 180. So in this, theta is equal to 180. So work done is equal to given by F dot S, as theta is 180. So in this case, work done by frictional force would be less than 0. Coming to next part, which is part D. So in part D, what he's saying that work done by applied force on a body moving on rough horizontal plane with uniform velocity. As he is saying, the body is moving with uniform velocity. So from this we can say that the acceleration of body would be 0. So acceleration of the body would be 0. In me, the person is applying a force F1 in this direction, and the friction applied by the ground in opposite direction is equal to F, as velocity is equal to constant, which implies that acceleration is equal to 0. Now in order to find the work done by external agent who is applying the force F, so work done is equal to F dot S. So the block is moving in this direction with constant velocity v, so displacement would also be in this direction. So work done is equal to F dot S, which is greater than 0, as theta in this case is equal to 0. So work done would be greater than 0. And moving to last part, work done by resistive force of air on vibrating pendulum in bringing it to rest. So as we all know that work done by air is opposite to direction of motion. So the air resistance is in direction opposite to motion. So if force is opposite to direction, due to air resistance, the force is opposite to motion. The force is opposite to motion. So from this we can say that angle between force and displacement would be 180. If theta is 180, so work done would be less than 0.